Math 1030, section 8.2, graphs of functions. So in the previous section, we defined what a function was based on data. What we're going to do now is look at the graph of a function. Now, like we said last time, for a function, every input must have a unique output. Every x has to give a unique y. You never want to have an x giving two different y values. That's the problem. So the way we do this is we look at the graph. Now, if an x value has two different y values, it means you have two vertical points on top of one another. And that's a problem because that's not a function. So the way that we check a graph of a function is using the vertical line test, sometimes called the pencil test. If you have any two values on top of one another vertically, well, that means it fails, and then it means it's not a function. So what we do is we look at the graph, we scan it with our pen or pencil, and if we see any values on top of one another, that means it's not a function. Let's take a look at these. We have this curve right here. If I scan it with a vertical line, notice we have 2 points on top of one another. That's a problem? No, that's not a function. What about this circle? Yeah, there's definitely places where you have 2 points on top of one another. No, that's not a function. This vertical line, definitely not. You definitely have points on top of one another. What about this? Well, if we scan it, we don't have any values in common vertically. So yes, this is a function. Practice problems will work the same way. Try it out. Here we have this ellipse. Nope. Not a function. Now this. We have these two curves. These two curves are never going to intersect or be on top of one another. They have this boundary here. So yes, that is a function. Here, no values in common. Yes, that is a function. This V-shaped graph, no vertical values. Yes, this is a function. Okay, in the previous section, we talked about finding the domain and range in terms of data. Let's take a look at how we can do that with a graph. Now remember, domain refers to x values, range refers to y values. We're going to revisit interval notation. And remember, interval notation is about boundaries. We look for the extremes on the left and right side. So for this graph, we have the line segment here from here to here. For the domain, remember, we're looking for left and right. So this, the most extreme value to the left is 1. To the right, it goes to 4. Now, because these endpoints are included, we want to use brackets to say, okay, include both of those. For the range, you're looking for the bottom to top. The smallest y value is -4. The largest y value is -1. We do want to include those endpoints, so we include those in brackets. Now for part B, we have this curve shape. We have this included and not included over here. So for the domain, the smallest value to the left is -2. The largest value to the right is +2. Now on the left side, we have solid, which means we do want to include it. We put bracket there. Here we have an open circle, which means we omit it, we leave it out, so we put parentheses over there. For the range, The smallest y value is -4. The largest y value is 0. Now, because this point here at 0 is included, it does exist, we're going to put a bracket there. Now, you might be wondering about the -4, because it's included here, but not included over here. Because the value of -4 does exist somewhere, here but not here, we do need to include it, so we're going to use brackets. For this next one, the domain, the smallest left value is -1. The largest right value is 3. Do not include it on the left. Do include it on the right. For the range, the smallest y value is -4. The largest y value is 2. Do not include it on the left, or I should say on the bottom. Do include it on the top bracket. For this last one, we have this kind of oscillating function. It goes up, goes down, goes up. For the domain, the smallest x value on the left is -2. The largest x value on the right is 4. They exist at both ends, so put a bracket. For the range, the smallest y value is -3. The largest y value is 3. Both endpoints exist, so we use brackets. The practice problems will work much of the same way. Now we have something different here in that we have some infinite graphs over here. Look at this graph. It's going to continue moving to the right. It's going to continue moving to the left, indicated by these arrows. So for the domain, there's no smallest x value. It's going to continue moving to the left. So the left-hand boundary is -infinity. To the right, it's going to continue moving to the right forever. So the right-hand boundary is infinity. And remember, with infinity, you always use parentheses. Now for the range, the smallest y value is -5. It's going to continue going up forever, so that'll be infinity. Because this point exists, we use bracket, parentheses over here. Now for this next one, we have this kind of up-down graph here. The domain, smallest x value is -5. Largest x value is 5. Omit it, parentheses on the left. Include it, bracket on the right. For the range, the smallest y value is -2. The largest y value is 2. It exists in both of those places, so both get brackets. Now for the next one, we have another infinite graph. It's going to continue going to the left. Domain. So in the left, there's no boundary. That'll be -infinity. The largest x value is going to be 2. Bracket here, parentheses here. The range. The smallest y value is 0 included. It's going to continue going up forever, so that'll be infinity with parentheses. Now this last example is going to be actually very similar to this one in that in the domain. Continues going to the left, continues going to the right, -infinity to infinity. For the range, the smallest y value is -3, included. Continues going up forever, that'll be infinity with parentheses.